Testing 1 2 3. Testing 1 2 3. Testing 1 2 3. Can you guys hear me? Okay. Good evening, everybody. I'm Gregg Lebovitz, and I'm with FP Complete. And this is the non-technical part of the talk. So the guy who comes after me, Nikhil, he'll be actually probably digging into some Haskell code. I'm going to tell you about the work that we're doing to make Haskell a little bit easier to use and how we got there and where we're going. Whoop. So the project that I'm talking about tonight is the School of Haskell. It's an online learning center, and it's focused on getting new people and experienced people the right content so that they can essentially learn new stuff and play with it without having to play around with GHCI or download software and trying to get it to install on their particular platform. So it's a web-based service, and it came about sort of by accident. So the agenda is that I'm going to explain some of the design goals that we had and tell the story behind how we got to School of Haskell. I'll demonstrate some of the implementation, and I'll give an overview of the architecture we're using. I just want to point out that the architecture was really focused on the entire development center that we're building, and the School of Haskell is taking advantage of that. And so you can think of the School of Haskell as almost an early release of what's to come. And I'll discuss that architecture behind it, and then I'll talk about how we intend to use that architecture to do future really cool stuff, hopefully really cool stuff. And then I'll talk a little bit about our milestones. So FP Complete was founded almost a year ago. I was, I think, employee number 2. Bartaj might have beat me. I might have beat him. And the goal is to create commercial Haskell software. And the plan of record at the moment is to get something out there as a software as a service platform so people can experiment with it, and then also provide an option to deploy as a VM or to the private cloud, and then very quickly get to something that you can run either on a server at your company or on your own machine. And even further out, we're going to focus on deployment, making the applications easier to run, which means things like deployment configuration, monitoring, exception tracing or exception resolution, interoperability. That actually probably will come further than further out. And that's interoperability with things like the JVM and later on the CLR that's part of .NET. And we have our eye on what Gershom and some of the others have presented as Cloud Haskell, and we would like to get into the area of actually enabling distributed applications and make Haskell useful in environments where people need redundancy and automatic failover, such as in the telecommunications market. So these are the players that started out. We actually have 10 or 11 people. They include people like Michael Sloan, who Carter just said that he knows, Emmanuel Borsboom, and John Wegley, and a few others that are working on the hardware. And then I have a team that's focused on product management and sales. Because in a startup, you do everything. So the 4 ingredients of what we're building are learning, development, building, and deploy. And we're trying to make that as easy as possible. And so we're building tools to make development, such as an IDE, easier, and then tools for building and deploying, and later on configuration management. Our first focus was on getting a product out there as soon as possible and making it free to the world. And we were going to do what we called the Student IDE, which would be a lighter version of what our development center is going to be. And it would have fewer features, but it would be available earlier and for free. And we would also at the same time build a community education center where we would ask people in the community who have really good tutorials and really good courses to share them, and we would have one place to do that, and we would organize it in a fashion where we could point you in the direction of the information that would be most useful to you. Bartosz had this great idea, which was, instead of doing the IDE first, why don't we make the Learning Center interactive? So we'll build the infrastructure that we were going to build anyways to do the IDE, and we would have the first editor be an embedded version that you could put into a tutorial, and then your students, rather than having to jump around between a runtime environment and a tutorial, would be able to just do the exercises or play with the examples right in line in the tutorial and run them and see the effects. So that became the School of Haskell, and we released that technically at the end of February, and building on that framework, we're building something called the Haskell Development Center, or Haskell Center, which is going to add the real development tools and build tools and deployment. And then we are going to try and make that easier to do with the infrastructure necessary to bring us up to the same level of some of the other languages for running large-scale applications. Not that it's impossible to do, it's just that everybody who deploys Haskell in a large scale builds their own, and we'd like to help people get there faster. And then we'll look at how we can fold distributed Haskell into the environment. So we, as I said, we wanted an early version of the educational IDE, and we ended up with this interactive learning center. So it's tutorials embedded with an editor. And what we found as we initially rolled this out, that the tutorials, in order to get all of the Haskell infrastructure in place, the imports, the pragmas, would be daunting to somebody who was just beginning, or it would change the focus away from the actual exercise or example you were trying to present. So we went a step further, and we made it so that you could have a whole Haskell program, but only show a snippet of it. And then your tutorial student could play with that snippet. And I'll talk a little bit about that later on. The back-end infrastructure was really focused on making it efficient and secure. And efficient is really, really important, because when you talk about free services and you're running on Amazon, you don't want free services to bankrupt the company. So we had to find a way to allow lots of processes to run, and to do that in a way without incurring a lot of cost. So we built this back end. We focused on secure content management, since we're going to be actually working with people's code. And we would allow integration with GitHub, and then in the early version of the IDE, we'll actually extend that to private Git repositories through SSH. So as I said, the School of Haskell is an interactive online service, and it allows active code, and the accounts are free. What's really interesting about the way we approach this is we not only allowed you to display examples and run them, but also we built a set of tools based on CodeMirror that would allow you to develop the content and preview it as you go along. So you actually can connect to the site and create your own content and publish it. And that makes it easy for people to leverage courses and tutorials that are already out there. And as a proof of concept, I hired somebody who actually ended up being a full-time person who's doing our community relations. His name is Chad Shearer. He took Brent Yorgi's course that he teaches at the University of Pennsylvania on Haskell and began converting it to an online version. And we're up to about chapter 6, and there's 3 more to go. And it turned out that it was not a major task to start doing this conversion. So we think that we made it in a way that allows people to leverage what they already have. So one of the people we're talking with is Jeremy Shaw, trying to get him to take his tutorial and move it over. And I think that's an easier task because he's already in Markdown, and he already has examples that he could just embed directly in the Markdown language. And I'll talk about the Markdown in a minute. So how many people have actually played with School of Haskell? Okay, so I suggest that you go to the site and sign up and play with it, create some tutorials, and you'll see the benefits of what we're doing. So the features are active code and GitHub compatible Markdown. So if you wrote something using GitHub Markdown or probably any standard Markdown, you can immediately put it into our a tutorial system, and then we give you some extra tags and such so that you can make your code examples active. There's really not much more to it. It's just putting the tags around your code, and it immediately executes or becomes executable when you run the tutorial. And there's buttons that allow you to build and run the code very quickly. We haven't had very many complaints about performance, so the back-end infrastructure that we built, focusing on efficiency, really does seem to meet its goal. And the idea is to provide a whole toolkit for creating that Markdown content. Okay. So when we built this, we focused on 3 distinct areas. We decided that we were going to make the editor in the browser, mainly because it was the most effective way of getting a GUI working with Haskell in a very short amount of time. We could have gone down the path of GDK or some of the other front-end libraries, but they seem to have various issues. We have a web-based server that serves out content to the client, though most of the editor and the runtime that the user sees is running in the browser itself, and they interact with the web server when, for instance, they want to run the code, which it then gets sent off to the server, compiled, and run, and then shipped back so that they can get standard output or visual presentation if they're building a web service. And then there's a set of standard cloud services that we use in order to provide storage and messaging and other services that are necessary for keeping track of the information that you design and build. So the web-based client, it's written almost entirely in JavaScript. Some of the JavaScript is actually in Fay, so that we could write more reliable code. And it implements both the user editor and the editor used for building the tutorials. All of the tutorials are based on Markdown, and we decided as proof of concept that we would build our entire website in Markdown. So Michael Snoyman built an engine in YESOD around Markdown, and when you go to our site and you go from page to page, they're actually using our Markdown. And that allows us to, in our website, anywhere we want, to put the active code. The way it actually works is that the content is rendered in HTML, and then we render or we overlay the code that's displayed with Code Mirror, so that it looks like it's embedded, but it's really an overlay. And you have controls to control what's displayed so that you can highlight the example code in your tutorial. So the front-end services that Michael built are really focusing right now on storage and building and running. On one side, when you, for instance, run a piece of code in the tutorial, the code, as I said, gets shipped off to the front end, we call it, and we create an output window and a communication, two-way communication. So you can actually input into the window that gets created, that gets sent back to the application, and then standard output gets shipped back. If you're using a web tutorial, so for instance, if you're running YESOD or you're running, I never really got that pronunciation right. People say YESOD, and other people say YESOD. So I think YESOD sounds more Hebrew, so it's probably correct. So the web tutorials actually launch a frame inside of the tutorial, and you can render HTML directly in there. So if you create a website and it sends back HTML, then it will be displayed right in line with the tutorial. And it actually uses the underlying browser, so you can get fairly sophisticated. I imagine that you could use whatever the browser provides. So, for instance, if it did WebGL, I imagine you could generate that. And the frame is bound to a particular URL that is a running instance of your web service. So you can't change the URL, but it gives you access to that web code. So the Markdown extensions that we added look like this. And so if you have some Haskell code, you just do 3 ticks, active the Haskell code in 3 ticks. And when you present that to a user and they browse your tutorial, whatever you have in this active statement will appear inside of an editor, and will give them buttons for running and viewing. If you have the active code and you put show around a particular segment, then only that segment is shown. So you can end up with a 20-page Haskell program, not that anybody ever really does that, but you can end up with a large Haskell program and only present to the student, or the tutorial student, a small snippet of that code. And then they can play with that code. And as long as they don't change anything that interferes with the rest of the Haskell code, for instance, introducing a new symbol that is undefined, it will work. And if they want to actually look at the entire code, there's a button that they can press, and it will show the entire program so that they can see what they have to interact with. So this is an example of a console application. I tried to pick something really simple. It has a main that essentially asks you for your name and prints it out. So I'm going to go over to the site, and I'm actually going to show you that code. So there's the edited code. And now, if the gods are with me and the network is working, I should be able to preview that. And there we go. So I can preview it inside of the tutorial. So I have my markdown and the active code. And then if I come over here and press the run button, it'll go off and compile it. It'll ask me to enter my name. I'll put Gregg. And there we go. So what's happening is, over on the other side, we are creating a container inside of our virtual machine on AWS, and it builds a runtime environment on the fly. It loads the code into it, it compiles it. Actually, it has the compiler in the runtime. And then it builds this two-way channel and spits out the output, waits for the input, and then sends that code back and continues executing the application. So the YESOD application that I built, and I picked YESOD because it was easy for me to send email to Michael and say, give me a bunch of YESOD code that I could do as a demonstration. But this would work with Snap, or this would work with Hapstack if you are inclined to use those frameworks. And essentially, the only thing that I really want the people to see is the code from here down to here. And all of this header stuff, if you will, the pragmas, the imports and such, I don't want to complicate my presentation to the student on the first exposure to YESOD code. So what I'm doing is I'm putting in shows just around the code that I want to display. And as I said, if you put in shows, only that code will be displayed. And it will look something like this. So you can see that I have the data statement, and then I have my callback functions that get created from the YESOD parse routes. And then I fill in the code, and I have a working application that should just display welcome to my website and allow you to navigate by clicking on a hyperlink. So let's take a look at that. We'll go back to my content, and I'll try the YESOD application and put it in the editor alone. And you can see it's the exact code that I had in the example, including the show statements. And this time I'm actually, rather than talking about it, I'm going to actually run it. And what happens is I get a window down below where it's not only compiled the code, but it's loaded a YESOD instance into a running container. It communicated with the virtual host manager, which actually set up a route that will take the instance, which is operating at some address in some port, and will use a front end to take the request and map that into that running instance. So if you wanted to have, for instance, a service that's running on port 80 at a particular IP address, then the front end would map your destination name with the port 80 and map that into the port and the IP address of where your virtual web server is running. We're using, I think, Apache for that. So Apache is doing our routing. And then I can click on About Me and go back and forth. So anybody have any questions? Yeah.
I can imagine there are some situations where it might be beneficial to see the whole program, and other situations where it's beneficial to see just a snippet. Do you have thoughts on what might, or whether I'm right, and what might distinguish between the situations?
Well, I think that it's at the discretion of the person doing the tutorial. So if I was doing a tutorial where I was focusing on how to use compiler pragmas, or I was focusing on the input, output, the export capabilities, then I probably would want to show the whole program, okay? But if I'm doing a tutorial for a beginner and I want to let them play with one particular aspect of Haskell that I'm discussing in my tutorial, I probably don't want to confuse things with the rest of the application. So more advanced tutorials tend to show more code, and less advanced tutorials tend to show less code, though that's not always the case. It's sort of, experts want to see a lot more than beginners do. So one of the things that we were thinking about is somebody could actually write a fairly sophisticated numerical analysis EDSL or set of libraries, and rather than presenting everything as a do structure inside of GHCI, you could actually have them just writing the numerical functions and not worry about why they work. Okay. Okay, so I talked a little bit about the front end. The front end uses Yeso's Wamlet, but also dynamic HTML and Markdown. And we mostly use Markdown for our pages as a way of embedding the code inside of any given web page. And the decision to do that came about when Bartosz did a blog, and he wanted to have some example code. And rather than sending people off to the School of Haskell, he wanted just to be able to use that active code capability. And so we made the blogs use the Markdown and the engine for rendering Markdown and doing the overlays. So as a rule of thumb, we tend to use the Markdown, even if we're just going to present HTML. So when I write, for instance, as I said, I'm doing sales and I'm doing marketing, and I have to do things like collect information from people who want to, for instance, take online courses, or they want to join our open enrollment course that we have scheduled for June. We have to have a way for them to sign up. And so I'm using Salesforce as our sales tool, and I can go into Salesforce and say, generate a form for me that I can put into my web page that will collect the information and send it into Salesforce for use later on. Even though I'm using HTML, I have to put it inside of a Markdown page, just because of the way the engine works. The front end communicates via REST JSON and using AJAX from the client to access those REST APIs. And all the static pages, as I said, are in Markdown, and the Markdown pages can contain HTML, as I alluded to. So the front end provides the generation of the pages. It interprets the dynamic pages, the Markdown. It processes the request, and it brokers to the backend services. So the backend services are anything that's going to run or one of the services that is out on the cloud that allows us to run the School of Haskell a little bit better. So for instance, we use Loggly for collecting and aggregating the logs that come out of our server, and the system will, the front end will broker the communication between the applications and Loggly for us. In order to get the code to run, we divided the architecture into three pieces. One is what we call isolation services, and that's the part that allows you to run a piece of code inside of a container. And that container can either be just a process running inside of a shared multi-tenant system, or it can be a virtual machine, depending on how much resource someone needs and how much they're willing to pay for it. The web server front end, it manages all of the virtual hosts along with the HTTP requests. So it's running the School of Haskell, but later on it will provide the APIs for doing development. So it'll talk to the IDE, and it will do all of the services that allow you to run your application in a virtual machine, or launch it into a private VM if that's how you want to do it. And then I talked about the cloud services as being services that are consumed by us that we pay for. So these are the services we consume. This is our front end for managing all of the web services and brokering to these services. And it also brokers over to the isolation system that creates the containers. And as you can see here, that a container can be running under LXC, which we chose because of its flexibility. And within that container, you can have multiple processes, or we can have multiple instances as EC2 VMs for scale or for better performance. So I just quickly want to go through this. The isolation containers, on the fly, they have to create and populate the containers with whatever's needed to run and build the code. We have to launch and build the execute processes, and then build the channel back to and from the back end. The container, as I said, gives lots of options, and it's managed by an EC2 load balancer. So we can get scale if we want. So I'm just going to go through this part fairly quickly. So the front end is really just another collection of EC2 VMs or LXCs that are running web instances. So we actually can have multiple instances of our School of Haskell, or multiple instances of our web front end for development, and scale that by just creating more and more instances. And since they all talk to the same back-end services, from a user's perspective, it looks like a single elastic cloud. And the virtual host manager is responsible for doing all the routing for us. So there's a picture of it. Okay. These are the cloud services that we use. One of the ideas that we have as we go forward is to expand these and make them available to users. So when we launch the IDE, we're going to provide things like message queuing and other types of services that your application can use without having to go and get those services elsewhere. You could also purchase those and just communicate with them using the Haskell APIs for talking to those services. So the Development Center will provide requirements for more services, and as I said, we'll do for individual requirements. So the next step is to build the Haskell Cloud Development Center. That's the technical term. We're calling it right now Haskell Center. And it's going to have a code snippet-based intelligent editor. And what I mean by intelligent editor is syntax highlighting and being able to do context help, and to eventually be able to tell you when you, at the time you're writing the code, if you are violating the syntax, or if you have grammar errors. It'll be guided development, so someone who hasn't done Haskell before will be given lots of hints as they go along. So we're going to leverage the Google and various other capabilities in order to do that. So as somebody types along, we can make suggestions to them as to functions they can use and how they would use those and when they would use them. And then there'll be integrated help and learning via the School of Haskell, but also via Haddock and other documentation that's already available. It will have the build, test, and deploy capability, and deploy will have multiple options, as I said. It'll have repository integration. We're going to start with Git, and we're going to expand to other repositories based on demand. So there probably will be some Darks integration. As we go more and more into the commercial world and we bring people on board who aren't using Haskell now, we'll probably see things like ClearCase and Perforce. And so we'll have to support those. I once did a project with ClearCase, and I would, anybody using ClearCase? Anybody love it? I once did a government project with ClearCase, and it was truly a memorable experience. Okay, so we're getting our libraries from Stackage, so we're encouraging people to try and put their libraries on Stackage to give a little bit, another level of stability. And then we're going to focus on scalability, and we're going to have a build system that may or may not use Cabal, depending on how well we can integrate Cabal. But we will be able to import a reasonable subset of Cabal functionality from Cabal files, and we will always be able to export your project as a Cabal file for use elsewhere. So we want to maintain compatibility, but we want it to be easier to use. Not a problem for the people in this room, but easier to use is going to be more and more important as we go into environments where we're encouraging people to adopt Haskell. So I don't know why it's not moving forward. So more next steps. We're going to take the development center, which is going to start out as a cloud service, and we're going to build it so that it can deploy either directly on the client machine or as a server behind the firewall that will have the features of team sharing and multiple accounts and a integrated build and deploy environment. The service will be self-managed, but will be under support so we can give help, and it will provide updates from our services. Later on, we want to add application services to those VMs so that there's configuration, monitoring, profiling, event management. We want to provide some runtime analytics that are a little bit more integrated and easy to use. Right now, there are tools that will look at your logs and will analyze the output based on based on your compilation. We want to integrate those tools so that we can provide live metrics. This isn't something new. A lot of companies who are running large-scale Haskell have already done this. This is something that we want to just generalize for people who don't have the resources to build this themselves. Okay, so I was talking to Gershom. So we have a project going on for running Haskell in the JVM. The architecture is being done by Andy Adams-Moran. He's focusing on a way of actually directly calling the JVM from Haskell. So you would have Haskell and JVM in the same process, and then eventually that will expand so that the JVM and the Haskell process could be separate, and they could use an IPC to communicate between them. Once we knock down the JVM and eventually get it right, I don't think it's going to be right the first time, but we will eventually get it right. Then we will do the CLR. We're going to try and improve some C++ interoperability. That will mean getting into the compiler and dealing with the name mangling and such. We want to provide support so that this JVM Haskell application might be able to integrate with some application servers that are being used in commercial environments like JBoss or WebSphere. Somebody brought up the idea of there might be a market for Haskell and Excel, and so I think that would be some area of interoperability. We're very, very encouraged by what Standard Charter's done, and we think that can be generalized in some way so that all of those companies out there that are doing the work through Excel would be able to do the back ends of that through Haskell. Of course, Visual Basic would screw that up, but yeah.
For the JVM, are you planning to compile Haskell to JVM bytecode or execute JVM other bytecode inside the Haskell process?
Execute JVM inside the Haskell process. We've bounced this around a lot, and you know, Simon Peyton Jones, his first reaction was, "Oh, let's get this working on the JVM, and we'll just have to make a lot of compromises." And it was like, yeah, that's a bigger project than what a 10-person startup is ready for. But you know, who knows? That might come in the future. Okay, and then we have our eye on Cloud Haskell. Everybody's looked at the presentation that Gershom did and the work that came out of, I think Well-Type did some work on it, and others. And Simon extended it and put it on Azure as an experiment, and it looks very promising, but it's a very low-level set of libraries, and it needs tools to make it easy for people to build distributed applications that have redundancy or failover. And so one of the areas where we want to focus once we get the other tasks done is to look at how we can leverage that. We'll do that once we're making some money, but that will come. So our plans are pretty concrete for the next month or so, and pretty darn concrete for the middle of the year, and then things get a little bit fuzzy. So, so we will have an alpha in mid-April. I know that because I'm talking to the engineers on an hourly basis on the features that we need in order to do an alpha. It's going to be a very limited alpha. It's going to be maybe 5 or 6 companies from various types of markets. So people who are using the cloud, people who are behind the cloud, people who have highly proprietary code that they don't want to share. And everyone's willing to work within the constraints of what our alpha is going to be. And hopefully that will shape what the beta will be. And we will get that out by mid-year unless we find that there's key missing requirements as we do the alpha. And then by the end of the year, we want to have some of the application services available. Not all of them, but a large chunk of them. And we also want to have the JVM support by the end of the year or sooner. And I made that less concrete because we've done the architecture, but we haven't actually built production code. So that probably will take longer than we think, as most things do. So that's pretty much what I wanted to talk about. I hope that it gives you an idea of what we're trying to do and the people we're targeting and how we plan to make Haskell much more of a household name over the next few years. And take any questions.
So what is a complete strategy for releasing code as open source or contributing to existing open source projects? Because like a lot of the projects you mentioned about using are currently open source projects, or and you talked about either improving those or building upon them. Like, is there any strategy that you could talk about for like releasing code that you're writing for giving back to the community? Yeah.
So anything that we do to extend open source code or build on open source code, we're likely to release back. So if we add libraries on top of Cloud Haskell, those will probably go back into the open source domain. Some of the tools that we build that integrate with our IDE might stay inside the IDE. So the way I would look at it is that the tools that we're building for commercial deployment we're probably going to hold those in a little bit closer, but we will always provide those to the community for use for free. Okay. Anything that we do in terms of libraries and infrastructure that is building on what the community has done, we will release back, and we're going to try and be as good about that as we can. Okay. Yeah.
How much is written in Haskell, and of that, how much was written in your IDE? How much of your platform was written in your IDE?
Well, the IDE isn't complete yet, so.
When will you start dogfooding the IDE?
What's that?
When will you start dogfooding it and then fixing what you forgot?
At the alpha. Okay, I wanted to answer the question. The only stuff that's not done in Haskell is JavaScript, okay? I would say dynamic JavaScript, because all of the JavaScript that's created, including code mirror code, we've moved as much of it over to Fay as we can, okay? We are really, I think, a hardcore user of Fay, because we're constantly having to make workarounds while problems get resolved. So I would say that probably 80% of what we're doing is in Haskell, and the rest of that is, the remainder is done in JavaScript, or when we're playing around with Linux containers, a certain amount of that has to be interfaced through Linux C and C++ libraries. But Emmanuel, who's building the infrastructure, is building it in Haskell. So we don't have anybody on the team who's not a hardcore Haskell programmer. Okay, and we'd like to keep it that way. Any other questions?
Let's see. Everybody knows spreadsheets are the most successful example of a declarative, quasi-functional programming system in the world. Now, everybody also knows that particularly Excel, and I think numeric suffers from this also, they're actually catastrophically bad, because you're constantly modifying the image with no way to backtrack. Have you considered improving numeric? I won't say Excel, because this is a anyway. Have you considered improving it? So, and this is along the line of Haskell development. You want something practical, but you also want something that, I don't know quite what word to use. I will use the word rigor. I ought to be able to press a button on numeric and then run it for 18 days with 20 users, and then I should be able to backtrace everything, the complete, in other words, well, sort of wrap Git around it.
So it's a very good question. And are we going to take on the problem of improving numerical analysis and the tools to do?
I was talking about the spreadsheet.
Spreadsheet. Are we going to build a better spreadsheet?
Yes.
Okay, and I'm going to give you an answer that I hope is going to, make that happen. Okay, We won't have the resources to do that in the near future, okay? But what we would like is when we get the infrastructure out there, that we will demonstrate there's enough of a market, okay, that people will build companies around the infrastructure. And if we have a channel into corporations that can reach much larger groups of people and make it commercially viable, then we're hoping somebody will build it, okay? And that we will provide a means of selling that through our channel, okay? And that's something that I didn't talk about, but if we're successful in the near term, okay, we want to do that sooner, and we want to have a vehicle for individuals or companies to push add-on tools or even applications through our platform and to our customers. And one idea that I had early on was, well, let's do the App Store of Haskell. Okay, but we don't really know what that means yet, and we don't know, we put in the infrastructure for billing for add-ons, okay? But we don't know what a store like that would be, how it would be structured, but we might imagine that it would be something that looks like what Heroku is doing with services. Any other questions? Yeah.
Like when you're talking about interoperability with C++, like, so is that something that's going to replace or FFI or?
We would probably just enhance the FFI. We would probably do that through groups who we would work with on the existing code.
So all the other JVM, CLR, interoperability are completely something new.
They would be completely something new, based on research or work that other people have done. Yeah. So if we do anything with C++, it definitely would just be pushed back. Okay.
So a good IDE needs a good compiler behind it. Is JHC ready to support a good IDE, like for intelligent feedback while you're coding? Can the modern compilers for Haskell provide what you guys need to do what you want?
That provide that information that plug into a bunch of standard programming like, are you talking about like completions or type of?
Well, I'm thinking of something like Agda has type hole programming, where you can have holes in your program, and then the Agda compiler will actually.
Yeah, well, 7.7, not holes. So GHC head does have holes. In the good sense. Is that what you mean, or?
Yeah, things like that. Like, are you guys going to be putting stuff into JHC as you go along?
So the question is, and I think that this is a more general question than just a particular feature, but how far are we going to be able to go, and what are we going to need to do in order to get further? And I think that a lot of really good work in the community is going on, and we're able to actually do a lot with what's available in GHC. But of course, what we're going to be doing is pushing requirements back, and as we go forward and we reach the stage where we have enough of a revenue stream, then we're going to hire people to help move things faster in the areas. And all of that work will be pushed back to the community. So we will not do anything to GHC that isn't to improve the overall technology from the community. I just want to point out that, and a lot of questions about what we're going to do. We look at what comes out of the Haskell community today as an incredibly well-oiled and put-together set of libraries and tools, and that's our upstream, okay? And we're part of the downstream, And I don't know if you're familiar with those terms that they use in Red Hat uses a lot, but we're looking at bolstering as much as we can in the upstream to help out the community, but we really want the community to be motivated to improve that as we throw requirements from other constituencies into the pool. And we will fund some of it, and some of it we hope will happen. Okay? So this is a symbiotic relationship here. All right, we're out of time. I just want to thank everybody for allowing me to share my ideas with you. And I encourage you to come to our site, and there's a feedback button, and I read every feedback message that comes in. So I would greatly encourage you to tell us what could be better, what you like, and let me know who you are so I can thank you.
Thank you, Greg. Yeah, the next talk is titled 1 Hour ML, so I wanted to make sure, it's a tight squeeze at that, so I wanted to make sure he has an hour. Couple quick things. I think Greg was too modest to really point out. One of the questions that came up early on was, this sounds great, you're building stuff for Haskell, how can I give you money? And well, their answer was, we're a commercial company, we'll have products, you can buy them. They have a product you can buy. If you have an employer that wants to pay you to learn about Haskell, they have tutorials that are coming up and people can register for, so people should check that out on the website and encourage get training or get your coworkers to get training and things like that. I want to make that clear. And also, I want to give a pitch for us that we need more speakers. We always need more speakers. We've had really great speakers thus far, but don't be intimidated. We need especially introductory speakers. To be an introductory speaker, you only need to know a little more than what you're presenting. So if you want to present and you know some things that you think you wish you had known 6 months ago before you started doing these things, then come talk to one of the organizers and we will set up introductory talks, and we want to make that happen. And also, one thing we were just talking about is we'd be interested in having a panel on how people deal with Cabal issues and sort of, library dependency workflows. Because there's no one right answer, but if like 3 or 4 people that all have strong opinions and a lot of experience in their own workflow wanted to come up and talk about whose ideas are better and worse and how they all survive it, I think that would be an interesting panel for a lot of people to learn the variety of approaches from. So if you're interested in that, come talk to us. Other talk pitches very welcome. Okay, Andrew is going to talk about 1 Hour ML. It's impressive to have ML in a couple days, much less an hour. And you're going to learn something about type systems. You're going to learn something about, parsers, the entire tool chain. So come on up and let's get started.